So you,
4 of them were here and then one got put in when they put in the extra zone on this one that you looked at.
there's only 2 zones on this system here.
On this one, yeah,
Yeah,
but it started with 1 and they came earlier this year and put in the second one.
is that when they put the bypass, that had to be when they put the bypass in.
I don't know, I mean, obviously I'm not up there.
But probably that's,
But see, the
But
thing is.
it worked the first season, last one.
that would have been before the bypass,
Yeah.
before they came, cause they came in May, I think.
But I don't know who did this, but you can't have a duct this big feed 3 ducts this big, okay? It just doesn't work. It just doesn't work. And then another duct on top of that feeds 2 more ducts. So it's designed for failure. I mean, it's designed for failure. It will never properly work right. Never.
And what do you think was the difference before they did this last one that actually allowed it to work?
Because it didn't have any zoning on it. So in other words, you're
On that
using,
one unit, yeah.
right, you're using the same amount of electricity, the same amount of gas. So in other words, you're actually using 3 or 4, either twice as much, 3 or 4 times more gas than you actually need to heat the one room. Because the furnace is burning 80,000 BTUs of heat, of gas, every single time it comes on. Okay? So if you're doing a single zone, you have to remember, let's say you're doing this room. The cold from that zone, that area, this area over here, all comes into here. Okay? So basically to heat a single room, you're using the same amount of gas to heat everything. So why have a zoning system in? I can see having one for the front area of the house and one for the back area. And the back area is the bedrooms, so when you go to bed, it does that area. In the front and during the day when you're out here watching TV in the kitchen, wherever you are, you're doing this area. That I can understand. 2 different systems for each side of the house. That I can understand. But the thing is, a zoning system, you're still burning 80,000, all 4 burners are coming on. It's not like 2 burners are coming on because you're doing a single area in the house. You still have maximum gas consumption every single time you come on, they come on. They put 96% efficiency furnaces in, but they only gave you single stage heating. There's no energy efficiency with this furnace except for the heat exchangers on it, okay? Yeah, you don't lose as much heat through the vent piping through the roof, but the thing is you have no low and high stage heating on it, okay? Which you should have on a 96% furnace. I mean, that's what they're all about, is the high efficiency. So in other words, right now, every time your furnace comes on, you're burning maximum amount of gas every single time. There's no savings in it. When your blower motor comes on, you're using the maximum amount of electricity. The thing is, you're producing more heat than can leave the system. So the temperature inside the furnace gets so hot that the safety switches are shutting it off. The fan, you don't know it's happening because the fan never stops running. It's still cooling off that heat exchanger. Once that safety switch resets itself automatically, once the temperature gets cool enough, then the burners come back on. So you're short cycling your system every single time because the air has no place to go because the ducting system is way off on this system.
Okay.
Way off.
Okay.
Okay? I'm giving you 39 years of experience on this.
We appreciate that.
Airflow dynamics is one of my specialties. Okay? So here, you got that piece of paper? Let me show you what you've got. Okay? So you have a 12-inch duct. This is 12 inches. That equals 480 CFM, cubic feet per minute of air. Okay, it comes off here and here. This is a 7-inch. That is 110 CFM of air. And this goes to a 6 and a 6. And these are 75 CFM of air. So you have 110 trying to feed 150. Okay? Now, so at this point, this 480 feeding this duct is now down to 370. But this continues as a 12, and this goes to a 9. And then this reduces to a 10. This 9 is 225 CFM of air. This 10 allows 300 CFM of air. And this 10 feeds 2 9s. So this is 225. This is 225. So now you have 300 trying to feed 450. Okay? It doesn't make sense. There's no way you can get enough air through this duct to feed all these ducts. Because this all totals 825 CFM of air. And you have 480 being supplied out to it. So how can these ducts ever get the airflow it needs? This here needs to be a 16 inch. So a 16 inch, now this is 1,000 CFM of air. Okay? And then this comes up, and this is a 14. And this duct, instead of being 7, should be an 8 inch. So this is 160 feeding 2 6s, which is 150. Okay, so now you're dropping 160 CFM off of this, so that brings this down to 840. Okay, this is 700 CFM of air. Okay, so that's going to give this air a little bit more velocity, and this is going to go to a 9, which is 225. And this is going to go to a 12. And then we're going to have our 2 9s. So now we're going to have 480 feeding 450, the 2 9s. This 700 is going to drop 225 off of that. 225 and 400 is 700, or is, 715. No, 705. So you have 700 feeding 705. So this is all positive. Each duct coming off of that supply box is feeding the amount of air those ducts need. When the ducts get the air that it needs, the time it takes to heat that house is cut in half. Because you've got twice as much airflow coming out of your system than what's coming out of your system now.
Okay.
Okay? That's the proper duct design you should have. Not this. This does not work. This works.
So do we have similar problem on the other system?
Yes, of course you do. Now the thing is, your 18-inch return, that's 1,300 CFM of air. Your system's in the cooling mode moves 1,600 cubic feet of air. So the return air ducts need to be 20 inch. That is 1,700 CFM. So actually your filter is going to give you a half of an inch of static pressure. So that's going to drop this 1,700 down to 1,600. That's the amount of air your blower motor moves. As long as the blower motor can run at the speed it was designed to run by the manufacturer, you will not have repairs. The system will run as it's expected to run. Okay? Right now, there is nothing on your heating system or cooling system that is correct.
Okay.
Zero.
I know my job. Oh,
Yeah.
I know my job.
Okay.
all right?
Well, the numbers make sense,
Yes.
but you're kind of at a graduate level and I'm kind of at a first grade level.
Well, it's like this. You can't have a duct this big that needs air coming from a duct that's this big.
Mhm.
And that's basically what you have. Okay, you have a duct this small trying to feed a duct this big. And it doesn't work. Okay.
Okay,